Alright, let's start out with a little factoring, quick review here. First thing we always look for when factoring is a greatest common factor. What comes out of each of these? 2. The x squared plus 7x plus 12, because 2 times x squared is 2x squared, 2 times 7x is 14x, and 2 times 12 is 24. And then you're looking to factor just the quadratic in here. We kind of ignore the 2 for a minute. It just kind of carries down with it. And then 2 things that make 12 and add to 7. In this case are 3 and 4. So you get x plus 3, x plus 4. You have now factored that completely. Any questions there? If you can't take out a greatest common factor, then you're just going through the process of number 2 here, 8 times c, 3 times 10 is 30. You're seeing 2 things to multiply to make 30 and add to 11. In this case, 6 and 5. So you get x plus 6, x plus 5. Don't forget to divide by a. That's the piece that a lot of students forget. That reduces to 2. This is 5/3, so the 3 moves out in front. So you get x plus 2 and 3x plus 5. That is number 2. Okay, questions there? Just out of curiosity, you haven't got number 2, right? Well done. Number 3. You can't take anything out, so we've got 2 things that multiply to make 8. Negative 8, thank you. Add 2 times negative 4 and you get negative 7. So in this case that is negative 8 and positive 1. So you get x minus 8, x plus 1. Divide by a, or not by 8. It's my fault. Divide by a, which is 2. 2 is going to move out in front. This becomes 4. So we get x minus 4 and 2x plus 1. Yeah. Yes. Number 4, you always want your a term to be positive. So it makes it a lot easier to factor. The first thing I do on number 4 is factor out negative 1. It makes it a lot easier. So we pull out that negative 1. Then you have positive 3x squared. You have positive 4x. And you have negative 7. So it just flips all those signs. And then from there, so if we finish that one up over here, you're going to be factoring this piece. So 3 times negative 7 or negative 21. And 4. 2 things to multiply to make negative 21. And add to 4 are negative 7. Or positive 7 and negative 3. Okay, so you get x plus 7, x minus 3. Don't forget to put your negative 1 out in front. And to divide by that a term. So this cancels, makes 1. This piece moves out in front, so you get negative 1 times 3x plus 7. And x minus 1. All right. Yeah. Go ahead.
So whenever there's a negative in front of
Right here.
the x squared, yeah, do you always have to do negative?
I would always pull out negative 1. It makes it a lot easier. You can factor it without doing that, but it's much more complex. What did you come up with? Did you not do it? You did? Okay, so if you don't do it there, you could get an answer that would work, but it's much more difficult to do. So pull up that negative 1. Help you out. Okay. The picture here, the length of a rectangular garden. So we draw a rectangle. The length is 4 less than twice the width, so we'll label the width. Length is 4 less than twice the width. We've had one like this similar before. What is the width? Well, you'd have to, the area is 96, so A equals 96. So area is equal to length by width. So 96, if we plug these pieces in, is 2W minus 4 times w. So length by width. Okay. You end up trying to find your width. You'd have to solve for w. The only way to do that is to multiply it out first. So we get 2w squared minus 4w equals 96. Then move your 96 over. So you get 2w squared minus 4w minus 96 equals 0. And then factor out that 2. It becomes w squared minus 2w minus 48. You get two things to multiply to make negative 48 and add to negative 2. Negative 8 and positive 6. So you get w minus 8, w plus 6. You don't have to divide by a because a is 1. So you have a width of 8 and a width of negative 6. Which one will not work? Negative 6. Can't have a negative width, so your width is 8. Okay. In this case, it's yards. That was our label. So 8 yards. Okay, and you can check it. If I put 8 in here, I get 8. I put 8 in here, I get 16 minus 4, which is 12. And 8 times 12 is 96. Yeah. Because you can't have a negative length. Yeah. Good question. Negative 6 won't work because you can't have a negative distance there. Okay. Questions? Yeah. All right. What I'd like you to do right now is take out yesterday's assignment. I'd like to get everyone's attention back up here. I want you to look at page 236 of your student journal. Okay. And on page 236, hi. You don't, yeah. So just pay attention up here for now. Hey, everyone's focused back up here. On page 236 of your student journal, you see that today we have kind of two different patterns we're dealing with, and this is actually factoring special products. What I'd like to say about one of these patterns is first the perfect square trinomial pattern. They show it kind of in mathese, I like to say it, where they're actually showing you the numbers and showing you the pattern in general form, and then they give you an example over here. Just so that you're aware, this pattern right here, you could, and this pattern for that matter, you could use the factoring we've been doing over the last week. If you decided not to learn these patterns, it would take you longer to factor, but you could still do it. So technically today I could give you any of the problems we were going to work on, and you would still be able to factor them just based on the factoring we just did on the warm-up. All right. With that being said, I like to try to find shortcuts, and I think that's quicker if you can learn the patterns. So that's what we're going to talk about today. All the math is right there in the patterns. I am going to show you how to use them by actually working through some problems with you. Okay, so if you look at page 237, you can always go back to 236 and add notes, but page 237, okay, we have s squared minus 49. First thing I want you to do on number 1 there is identify what A, B, and C are. Write them next to it and tell your neighbor what they are. Okay, number 1, what is A, B, and C? Sarah, what's A? Okay, what's B? 0, and C? Negative 49. So really, if we wanted to, we could write this as s squared plus 0s. That's why we don't see an s there. Minus 49. Now technically, if we're using the diamond method there, or Lizzie's method, however you want to reference it, this little diamond here, what would go here? Negative 49. And what would go here? 0. And two things to multiply to make negative 49 add to 0.
7 and negative 7.
7 and negative 7. So this becomes s plus 7 and s minus 7. Okay? That's it. You factored it. We didn't have to divide by a because a is 1. And when we divide by 1, we get the same thing. Okay, let's try number 2. Identify A, B, and C on number 2. Do your diamond, factor it out. Okay, 2 things to multiply to make negative 81, add to 0. Okay, 9 and negative 9. Okay, so once again, there's our answer. We don't have to divide by A because A is 1. Tough? No? Okay. Now I'm going to pause on number 3 here for a minute. But really, taking a look at 1 and 2, there's a pattern involved here. If you, and I'm going to try to relate this pattern and the next pattern here in a while, but if you look at a quadratic or a squared, and you look at the front and it's a perfect square, which it is, and this is a perfect square in back, which it is, then we look for special properties. Okay? In this case, if there's only 2 terms, the thing you're looking for next is there a subtraction sign in between? Because if there are, then you're going to have 2 sets that only differ by having a subtraction symbol. So for instance here on number 4, is this a perfect square? Is that a perfect square? Yeah, that means this whole thing is a perfect square. Is this a perfect square? Is there a subtraction sign? Okay, now the subtraction tells us that we're going to have plus and minus. Okay? What goes here in the back? 5. It's the square root of that. Just like up here is the square root of that. What goes here? 5. Just like here, right? Square roots. What's the square root of 4g squared? 2g. You've now factored that. That is the pattern for difference of 2 perfect squares. We call this a difference of 2 perfect squares because they're perfect squares and you're subtracting. It has to be subtraction. You can't add. Okay. So, number 5, I want everyone to figure out the sets without having to use the little diamond. Just use the patterns. Mercedes? Plus minus, what's front term? 6. Back term. There you go. That's it. Square root of 121, right? Okay, Sarah. Before we do that, can I give everyone a chance to try those 2? Those are our 2 challenge ones. Go 3 and 6. They look a little different. Okay, treat them just like we did the patterns on the others. Okay, are they both perfect squares? Yes, there's a difference in between. So, square root of 4 or 16. Square root of x squared. 1x. There it is.
Yeah.
You cannot reverse them. Okay, you cannot call it 4 or x minus 4. Okay, 4 minus x and 4 plus x. Good to go? Sarah? You could, but it's gonna end up. It would end up you'd have to flip things around in there. Yeah, I wouldn't do that. Okay, so one of the ways you can use. Pay attention. One of the ways you can use difference of 2 squares is to do math in your head. You say 57 squared plus 53 squared or minus 53 squared. This is a perfect square, and this is a perfect square. Okay? What's the square root of this? Oh, no calculators. Come on, hey. What's the... Yeah, square root of 57 squared is 57. All right, square root and square cancel out. What's square root of 53 squared? So really what you're asking is, if you take the square root of a square, they cancel out, right? So take an easier number. Like if you had 4 squared, what is 4 squared? 16, and what's the square root of 16? 4. These two things cancel. That's what's happening here. What's 57 plus 53? 110. 57 minus 53. 4. What's my answer? No calculator. 440. Not 444. There we go. Okay, we could use that process that if you'd like to. I probably wouldn't do that, but I don't know when I'd use that as much. But okay, I want to take a look at the next page though. Turn that over. Tell your neighbor on number 13 if you can use the same pattern. Tell them yes or no and why. Okay, how many say yes? How many say no? Why is it no? Because what? Yeah, there's 3 things, man. You only use that other pattern. Difference of 2 squares only works on difference of 2 squares. There are 3 terms. However, with this pattern right here, you could, once again, go through and do this. Don't do it right now. But you could. 2 things that multiply to make 64 and add to 16. 8 and 8. So again, you're getting those same number right here. So this is x plus 8 and x plus 8. Now I will tell you this pattern also has to do with squares. Okay? Perfect squares. Seriously, dude. Not funny. Alright? You gotta use some funny puns if you can do that. How did we get 8 from this? Let's say we ignore this. How do we get 8? Square root of 64. Okay, take a look at this one down here. Using that same logic, what would this one be? 9. What goes here? What goes here? Why is it minus? Okay? Yeah, and more specifically, there's a minus sign right here. Okay? Here there is a plus sign. So this pattern right here, this pattern works if you have a perfect square in front and a perfect square in back. This is called a perfect square trinomial. Pay attention. If you can't handle it, then come right up here and sit. Otherwise, you're going to be sitting outside. Who? Looks like he's sitting there paying attention to me. Is this a perfect square? Is that a perfect square? Okay. The only thing we really haven't paid attention to is what happens with the middle term. Well, we have to actually figure out, not every perfect square is going to work like that. Like, just because it has a perfect square in front and in back doesn't mean you can write it like this. Right? If we were to multiply this out, we get x squared plus 8x, and I know it's not telling me to do this, plus 8x again, plus 64. Well, here's the perfect square, and here's the perfect square. The middle number has to be 2 of these two. That's 8x, right? You have to have double that. This is a squared, negative 9a, negative 9a, and positive 81. There's our perfect square and our perfect square. You have to have two negative 9a's. Negative 9a, negative 9a. You have to have two positive 8x's. Positive 8x, positive 8x. Everyone see that? Okay, question? It'll always work if when you're done, so like on this one, what's the square root of this? 6. What's the square root of this? What goes in the middle? Plus. No, not plus and minus. Just plus. Now, does it work? Well, what's 6c times 7? What's 6 times 7?
42.
Okay. You have 42 here and 42 here. Does that make 84?
Yeah.
Then it works. Okay? So my question would be, if that worked here, and, well actually, you guys give me an example when it won't work. When can you have a perfect square in front, a perfect square in back, and it's not going to work out? What would it look like if those are my three terms?
Would you have a decimal? Let's have 3 in the middle.
Well, they're not. It's up to you what you want them to know. Come on, pick a number to go out in front and pick a number to go out in back. No, you guys do it on your paper right now. Okay, give me a perfect square for right here. 64 what? X squared. Okay, perfect square in the back. 4. Okay, give me a number. By the way, this is always plus here. Give me a number that I can put here that will not make it work out. Because right now we'd have 8x and we'd have 4, or 2, right? Come on, man. Give me a serious number. 3? Okay, I put 3 here. Let's say I put plus. Okay, that's a valid problem. Does it factor to this? Well, 8x times 2 is 16x. 16x and 16x is 32. It's not 3. Okay, even if I put x here, it doesn't work, right? Because when I multiply this out, I get 64x squared. Positive 16x. Positive 16x. And there's my 4. So there's the 4, there's the 64. But in the middle, I need to have two 16x's, or 32x. I don't have it. So in order for it to work, that'd have to be 32. Is everyone seeing the pattern there? You have to look for that pattern. Otherwise, you just have to factor it the normal way. Okay. What I'd like you to do before we move on here, I want you to try number 18, number 15, and number 14. 18, 15, and 14. Make sure they work. Okay, there we got them. Hey, guys, we really have two things left here. First one's an easy one. How many p plus 14s do we have? You have 2. So most of the time you'll write your answer like that. That's the answer. It's quicker to write. You have 2 of those being multiplied together. You have 2 of those being multiplied together. And you have 2 of those being multiplied together. Any questions on that pattern? Remember, you can always do it the other way. It's just quicker this way. The whole reason we go through and do these is so we can solve the equation. So the second piece here is to actually be able to look at some problems. For instance, this one. It says solve the equation. It says equals 0, meaning we factor, and then we go that extra step. So is this one of our special cases? Yeah. Go ahead and factor it. Now, if you know how to do it, you should be done already. What is it? Good. X plus 12, x minus 12 equals 0. What answer do you get here? Negative 12, and here? Positive 12. So my solutions are x equals plus minus 12. And remember, it has to equal 0 first. So like on this one, do you have a question?
Yeah, why would it just go like when you're moving it down, why would it go to like negative 12?
Because you're saying what makes this 0. So if x plus 12 equals 0. Yeah, that's how we get the negative 12. Okay, this one we have to set equal to 0. Go ahead and set it equal to 0 and solve it. Number 20. Okay, I started it out for you. Okay, set it equal to 0. Perfect square, difference. How am I doing? Very good. Yeah, nice job, guys. That would be 3y, right? That takes square root of 9y. Okay? If 3y plus 7 equals 0, 2 steps, subtract 7, divide by 3, that is my answer. And if 3y minus 7, this part, equals 0, add 7, divide by 3 are my 2 steps. So my answer is y equals plus minus 7/3. Okay, last problem, number 21. Give it a shot while I'm handing out your assignment. Go ahead and try that one. Okay, it's perfect square trinomial. How many got it? You're good. Hopefully that quick. Yeah, man. Okay, your assignment, you got it in front of you. If you have any questions, make sure you ask me there.